time feels obvious. You wake up, you age, you remember yesterday, you wait for tomorrow. Everything in your life seems built on one simple fact: time flows. But modern physics and philosophy have a way of disturbing simple facts. Because when scientists and philosophers ask what time actually is, the answer becomes much less clear. In relativity, different observers can disagree about which distant events are happening now. In quantum gravity, time may not even appear as a fundamental variable in the deepest equations. And in philosophy, some thinkers argue that what we call the flow of time may be more about human experience than about reality itself. So, could time be an illusion? Not in the sense that clocks are fake, not in the sense that change is fake, but possibly in this deeper sense. Maybe the passage of time, the feeling that reality is moving from past to present to future, is not a basic feature of the universe. Maybe it is something that emerges from physics, memory, entropy, and consciousness rather than something built into reality at the deepest level. To understand that idea, we have to separate three different questions. First, is time real in physics? Second, does time actually flow? And third, why does it feel like it does? Those are not the same question, and mixing them together is where most discussions about time go wrong. Philosophers of time distinguish between time as an ordering of events, time as measurable duration, and time as experienced passage. The Stanford Encyclopedia's discussions of time and temporal consciousness make clear that debates about passage are not identical to debates about clocks, causation, or change. Before Einstein, many people assumed time was universal. The universe had one shared clock, a single now stretched across everything. Relativity shattered that idea. According to special relativity, simultaneity is not absolute. Two observers moving relative to each other can disagree about whether two distant events happened at the same time. Einstein Online explains this directly. Statements about durations and simultaneity depend on the observer's state of motion. There is no single physically privileged now built into the structure of special relativity. That sounds technical, but the implications are huge. Because if there is no universal present, then the idea that the universe is being sliced by one cosmic now starts to look more like a human habit than a law of nature. This is one reason many philosophers and physicists are drawn to some form of the block universe picture. In that picture, space-time is treated as a four-dimensional structure in which past, present, and future are all parts of the whole. The SEP discussion of modern physics and becoming notes that relativity strongly pressures any view that wants to treat one global present as physically special. If that sounds disturbing, it should, because the block universe idea suggests that time may not be moving at all. Instead, all events simply exist within space-time, and what we call the passage of time is not something the universe does. It is something we experience from within it. That does not mean your life is frozen. It means reality may be less like a movie playing frame by frame, and more like the entire film reel existing at once. The debate is philosophical as well as physical, but relativity is one of the main reasons eternalist and block-style interpretations remain so influential. But if that is true, why does time feel like it flows? That question leads to the arrow of time. At the microscopic level, many of the basic equations of physics do not care much about the direction of time. In a rough sense, they often work similarly whether time points forward or backward, and yet your everyday world is full of asymmetry. Eggs break, but they do not unbreak. You remember the past, not the future. Smoke spreads through a room, but it does not gather itself back into a cigarette. The most common scientific explanation points to entropy. Entropy is often described as a measure of the number of possible microscopic arrangements compatible with a larger state. In thermodynamics, systems tend to evolve from less probable, more ordered states toward more probable, more disordered ones. That statistical asymmetry is a major candidate for why macroscopic time seems to have a direction. Reviews on entropy and the direction of time treat this connection as central, even while debating whether entropy fully explains temporal passage itself. And memory may be part of the same story. We remember the past rather than the future because memory formation is itself a physical process. Carlo Rovelli has argued that the psychological and epistemic arrows of time may depend on the same asymmetries that govern entropy and information. Recent work on memory systems and the epistemic arrow similarly asks why our knowledge of the past is richer and more structured than our knowledge of the future. So one possible answer is this: time does not literally flow. What flows is us. We are physical systems that build records, age irreversibly, and process information in one entropic direction. The feeling of movement from past to future may be the way a memory-making organism experiences a universe with low-entropy history and asymmetric information. That idea does not solve every philosophical problem, but it gives a scientific reason why time feels directional, even if the deepest laws are less committed to flow than we are. But the story gets stranger. In some of the deepest areas of theoretical physics, time is not merely non-absolute. It becomes difficult to define at all. This is the famous problem of time in quantum gravity. General relativity treats time as part of dynamical spacetime. Ordinary quantum theory usually treats time more like an external parameter. When physicists try to combine these frameworks, the result is conceptually unstable. Major reviews describe the problem of time as arising because the two theories assign time fundamentally different roles. In other words, one of the biggest clues that our current physics is incomplete is that we do not yet know what time fundamentally is. Some approaches to quantum gravity suggest that time may emerge rather than exist at the base level. Reviews in loop quantum gravity emphasize that once spacetime itself becomes subject to quantization, our everyday notion of sharp geometry and ordinary time cannot simply be assumed in advance. That is a radical idea. Not just that clocks run differently, not just that simultaneity is relative, but that time itself may be more like temperature or pressure, a higher-level feature that appears in certain conditions rather than a primitive ingredient of the universe. Some researchers pursue versions of this through ideas like thermal time, in which time is linked to statistical states and thermodynamic structure rather than assumed as a background absolute. These proposals remain debated, but they show how seriously modern physics entertains the possibility that time is emergent. Now, that does not mean time is fake in the lazy internet sense. You still age, causation still matters. Clocks still measure real physical intervals. GPS still has to account for relativity in order to work correctly. Real-world time dilation is not philosophy. It is physics, and precision systems depend on it. So the better question is not whether time exists at all. It is whether the version of time that feels most obvious to us, the flowing present, the moving now, the sense that the universe itself is advancing, is fundamental. And here, the answer may be no. Our experience of the present may be tied to consciousness, memory integration, and temporal perception, not to a special glowing edge sweeping through reality. Philosophers of temporal consciousness argue that the lived sense of succession and presence is a feature that demands explanation in its own right, and not one that automatically settles the metaphysics of time. This is where the debate becomes deeply philosophical. Some thinkers defend presentism, the view that only the present is real. Others defend eternalism, where past and future are as real as the present. Others hold intermediate views, like growing block theories, where the past and present exist but the future does not yet. The SEP overview on time lays out these options and explains why relativity creates pressure for non-presentist views, though it does not end the debate by itself. Some scholars argue that the block universe is the cleanest fit with relativity. Others argue that this goes beyond what physics itself strictly requires. Some defend objective temporal passage. Others think passage is a projection of human cognition onto a world better described by geometry and change. The live debate itself is part of the point. Modern science has not simply solved time. It has made the question stranger. So, could time be an illusion? Here is the most honest answer. Duration is real. Change is real. Clocks are real. Causal order is real. But the intuitive feeling that time itself is flowing from the past into the future may not be fundamental. That feeling may arise from how observers like us are embedded in space-time, how memory works, how entropy evolves, and how incomplete our current physical theories still are. And that may be even more unsettling than simply saying time is unreal, because it means one of the most intimate features of human experience, the sense that life is moving through a disappearing present, may tell us more about minds like ours than about the deepest structure of the cosmos. Maybe time is not a river carrying everything forward, and what we call the passage of time is the way a remembering, aging, conscious creature encounters that reality from the inside.